That shows that we have two kinds of charge: negative charge and what? Positive charge. So the positive charge, okay, is when you give out, all right, you become more positive, and the negative charge is when you accept more electrons, become negative charge. But however, we are going to also look at how charges are being produced. Okay, welcome to second semester physics in University of Port Harcourt. The course code is 112, electricity and magnetism. And I believe that another university, Federal University and also State University, who are also using the same scheme of work. Of course, in most of the universities, the same scheme of work. And first semester you did a physics 102, so physics 101 for those uniforms, which is mechanisms and properties of matter. Okay, then other universities have their own course code, but still the same thing. Maybe there might be other arrangement, but still mechanisms and properties of matter, which is the first aspect of physics that you are actually going to need before optics and then the rest of them. While other universities anyway combine both mechanisms and properties of matters and also optics and thermal physics, like in UST, University of Science, Science Technology in River State, Port Harcourt. They combine both optics and also mechanisms and properties of matter. But UST and University of Port Harcourt, Phase 101 is mechanisms and properties of matter is first semester, while second semester they have Phase 112 and Phase 115, which is optics, thermal physics, and then electricity and magnetism, which is done by different departments. So why I'm saying this is because this video is generally going to cover every aspect of university that handle this course, of course, who are also using the scheme of work. And of course, as we all know, electricity is electricity. Anywhere you go, the concepts still remain the same. Okay, so I would like us to follow accordingly, because I'm going to be working directly with this textbook. Now this textbook have different edition, like I said earlier, it has different edition, but the concepts, what we have inside is still the same thing: electrostatics, electric field, Coulomb's law, Gauss law, electromagnetism, Faraday's law, Lenz's law, and the rest of them, AC, they're all the same. But I'm going to follow this book accordingly, so that let it be a way of summarizing the book for students that may really need the assistance, okay, that may really need this, that may really find this video useful, okay, just to make the work easier for you. Okay, so I'm going to go through the concepts chapter by chapter, concept by concept, and then I'll also go to the calculations. Okay, but first of all, the concept will be treated, and the videos are going to be arranged accordingly. Okay, you can also check the playlist, you see them there. Okay, in the physics classroom, you will see that is arranged accordingly. So the concept comes in, then afterward the calculations, and you can follow the title accordingly to ensure that you gain maximum benefit of this video, okay, of this lecture. Okay, so like I said, first semester you looked at your various universities, you looked at mechanisms and properties of matter, and one of the topics you looked at was under gravitational field, and you also talked about under work energy and power. We also looked at, towards the ending of that chapter of that textbook, we also looked at what we call fundamental forces in nature, forces that arise naturally. Okay, and we looked at four of them. One of them was gravitational force, electrical force, magnetic force, and then nuclear force. Okay, and among these four forces, we were told that the gravitational force is the weakest of all of them. Okay, now we also looked at the what we call the Newton law of universal gravitation, that talks about the force of attraction between two masses. Okay, which is of course given as F equals to G m1 m2 all over r squared. All right, so this was the formula where we have the m mass 1 and m mass 2, and this is the distance of separation, and then this is the gravitational constant. Okay, and of course we also know that this force is also called the inverse square law. This formula is also called inverse square law. Okay, meaning that the force is inversely proportional to the square of the distance apart. So the more the distance, the more you increase the distance, the more the force decreases or become lesser. Okay, now we see that the mass 1, mass 2, of course mass is constant all over the universe. The mass have this kind of attraction, okay, between the other mass, okay, in the universe. Now when we come down to the second semester course, we talked about electricity. So we talk about charge. Okay, so along in the process of going this class, we are going to go through a Coulomb's law, a concept, okay, of electrostatics that also has a formula of this form. Okay, but first, what we need to understand is that the major thing that we need to have here is that this force of attraction, okay, holds in a gravitational field, while when we come to electric field, we also have the Coulomb's force. Okay, so we have it down there. All right, so like I said earlier, in the process of our concepts explanation in the electric field, we are going to compare electric field with a gravitational field. We also compare the two forces. Like I said, we have a similar force, like I've showed you earlier, okay, in the Newton laws of gravitation. So we are going to look at the Coulomb's force, F equals to K Q1 Q2 all over R squared. So it's also a formula that we look at them and then we'll make some comparison between these two forces, and we also from there we also look at mathematically why or which of this is greater, either is it the gravitational force that's greater than electrical force or not. We are going to look at the ratio of the electrical force with gravitational force, and then we'll now look at which of this is greater. Okay, so but basically we want to start from the concept of electrostatics. Okay, now electricity itself, of course, has to do with the movement of electron. From the word electricity, electric, we have the word from the word electron. Okay, the word electricity is being coined. So the movement of electrons around the nucleus of an atom give rise to what? Electricity. That means that if we are going to look at atomic concepts of electricity, okay, now first of all, the study of electricity is divided into two. Okay, funny enough, we have one of them is current electricity, and then the first one, which I was supposed to mention, is electrostatics. Electrostatics is number one, then current electricity, because first of all we have to look at the properties of charge when they are at rest, okay, or they are moving slowly, which we call a quasi-static, okay, semi-static. That means they are moving slowly while we discuss the property. Just like in our mechanics, we discuss kinematics and dynamics. Kinematics, talks about the motion of physical object without looking at the force that is causing that object to move. While in dynamics, we look at the motion and of course what causes that object to move, which we also know that force is the major cause of motion. Okay, so the same way in electricity as a concept, we also have it basically two divisions before we have other subdivisions. Okay, so we have the electrostatics, okay, where we look at the property of charge and charge system at rest. When the charges are at rest, we study their properties. Okay, we want to know more about them. What are the types of charges we have, and then when these two charges, or when charges interact, what actually happen in the vicinity of these charges. Okay, then like I said, we can also look at a quasi-static form of it, whereby we also assume it to move slowly. Okay, because of course charges are always in constant motion once there is a passage of current. Okay, so but if we look at them in that way, we cannot actually talk about the properties. Rather, we are going to look at them when they are moving slowly or when they are finally at rest. Okay, which we call it what the statics or the quasi-statics. Okay, so you can also check that, read more of that in your textbook. Okay, so that is what we want to look at, and that will actually take us to a deeper concept, where we are going to look at so many aspects of properties of charges as we progress. Okay, so now like I said, electrostatics is a branch of electricity that discuss the properties of charge and charge system at rest. Okay, so then what then is charge? Now if we look at our atomic concepts, okay, like we all know, atom is made up of electron, proton, and then the neutron. Okay, and that if you look at electron, if you look at the electronic model or atomic model, okay, so we have this, and then around here we have our electrons, then in here we have our proton and our neutron. In the nucleus here we have the proton, and then we also have the neutron, and then here we have our electron. Okay, now the proton is positively charged. We use letter E, small letter E, to denote charge. Okay, we call that fundamental unit charge. While the electron is negatively charged, while the neutron is neutral. From the word neutron is what neutral, so it has no charge. It's neutral. Okay, let me just spell here. This is neutral. Okay, all right. So now we all know that during chemical combination, look at the chemistry aspect of this. During chemical combination, that when electrons are combined, or when we have electron leaving a particular atom, then that atom become more electropositive. Okay, as more electron, when more electrons are being taken away. Okay, that means when that very object transfer more of electron, or gives more of electron, or donates electrons, that very atom become electropositive, and that atom that is accepting that electron become what? More electronegative. That's what we talk about, the concept of electropositivity and negativity. So it become more electropositive when you give out, and it become more electronegative when you accept. Okay, so now normally I use the sodium chloride for example. Okay, we have the sodium, then we have the chlorine, and the sodium itself here is 281, then the chlorine here is about 287. That is atomic number 11 and then atomic number 17. Right, now when this gives out, the chlorine, the sodium is a metal. Okay, so this is a non-metal, so the sodium is going to give out one electron. So as it give out one electron, it will become Na plus. It will become Na plus. Okay, that means it's giving out, and that makes it positive. So since it's giving out, then that means that it's going to be more electropositive. That means when you give out, become positive. Okay, so now, because we are going to look at it, because when we talk about electric field lines, this will also help us to define electric field lines, and to also help us to visualize what electric field lines is, and of course the electric field lines arrangement in an isolated positive charge and also in isolated negative charge. Okay, so we need to understand what this actually means. So now, why the chlorine is going to be C minus. Chlorine C minus means because it's accepting. Okay, so when you, like I mentioned earlier, when you accept, you become electronegative. Then when you give, you become more electropositive. Okay, so this is the atomic model, the atomic concept of electric charge. Okay, now don't forget that the electric charge itself, the charge of the electron and proton, the value is actually given as 1.6 times 10 to the power minus 19 coulomb. Coulomb is the unit for what? Charge. Please don't forget this, because we are going to be making use of this when we start our calculation properly. Okay, so this is what we have here in this case. Okay, so it is very easy to understand this when you use this very simple analogy or this very simple model to explain that. So of course, when you finish this, you notice that the chlorine is going to be 2 8, and here become 2 8 8. So here it becomes argon, and here becomes calcium. Okay, so you have it there very clear, and it's very good for us to understand that electrons electrons increases when a particular atom accepts accept electrons. Okay, that means it accepts, while electron decreases when there's depletion or decrease in electron when it gives out, when that very element gives out electrons. Okay, so this is the charge concept of this. And of course, this what we have here is basically called ion. Okay, but in this concept we are not discussing ion. In this physics we are not discussing ion. The ion concept is being discussed. The cation and the anion are discussed in the chemistry aspect of it, so you can read more in your chemistry. So we are only looking at what actually happens when atom gives out, or what particular atom particular electrons are being released from a particular atom, and when they are what happens also when they also accept a particular atom. Okay, so we look at the positive and the negative charge. So that shows that we have two types of charge. That means negative charge and what? Positive charge. On a pen to rub on your hair, you can easily pick a dust or paper. Okay, that shows that there are various ways we can also create charge. okay, which we're also going to discuss that, which is the induction method, friction method, and conduction method. We are going to discuss that in our next video, okay. But this video is only covering the background and the basis of electric charge, okay, and of course how electric charge has been produced. Like I said, don't forget this concept. These are questions they ask in the objective or in the exams. How are positive charge created and how are negative charge created? Positive charge is created when an ebonite rod, okay, is when a glass rod is rubbed with 6, while negative charge is produced when an ebonite rod is rubbed with 4. The question is where does this charge come from? So that will lead us to another concept we're going to discuss in our next video, which is what the principle of conservation of charge, which states that no charge is created, no charge is destroyed, but there's only a transformation from one form to another. So that's principle of conservation of charge. We're also going to look at another principle again that talks about that the net amount of charge produced in any process is 0. That means that if we say that the ebonite rod, okay, when it's rubbed with 4, give us a negative charge, and glass rod when rubbed with 6 give a positive charge. I mean, there is something that went on between these two objects, okay, before now. That is before they interacted. Something really happened before this. So we are going to discuss that in our next video. So check out the next video and see how we can cover up this section of the class. Thank you.
I still got joy in chaos. I got peace that makes